What's up guys, welcome back to the next video in learning awesome mathematics. My name is QD Azdan and you guys are watching my channel Koraun. Alright, so we recall our previous video about the logical connectives. We're going to go through again because we need you guys to understand from the last video. We will use letters such as P, Q, R and S to represent atomic statements. We refer to these letters as propositional variables. We have a symbol for each logical connectives. So our symbols are, as we said in the previous video, the first one is going to be AND, the second one is going to be OR, the third one is going to be if then, the fourth one is going to be if and only if, the fifth one is going to be not. So we say the wedge shape one, if we say in mathematics is conjunction, the V shape one, which is OR, in mathematics we say is disjunction. The third one, which say the right arrow if then, it's called implication or conditional, and sometimes we call this imply. Sometimes when you see the right arrow, we say that this is imply. And the fourth one, we say that the double-headed arrow, we say if and only if, and in mathematics we say biconditional. And the last one is this side horizontal segment and vertical segment, which is joined together, we say which is not in our in plain English, and in mathematics we call this negation. So we read this as P conjunction Q, P disjunction Q, P if P then Q, or P implies Q, P if and only if Q, and not P, or negation P. So we in this video, we're gonna go is statement with symbols. So in the previous video we've seen the statement with words and atomic statements, molecular statement. In this video we're gonna go with statements with symbols. P and Q is read as P and Q and called a conjunction, as we said in the previous slide. P, and you guys see this, there is a wedge shape here and there is a V shape here, is read as P or Q. So we read this as a P or Q and call it disjunction. P right arrow Q is read as P if P then Q and call that implication or conditional. And the next slide we're gonna go through this again, what is implication, because this is a wide subject in mathematics. You guys need to understand that, if the first part and then the second part. And P double-headed arrow, which heading towards P, and there is one towards Q heading pointing towards a P and pointing towards a Q. Makes sense, because if P if and only if Q, I would call it biconditional, because there is facing both ways. And you guys see here horizontal segment plus vertical segment, you guys join together, is called or you can see this is a corner of the box or corner of the roof, whatever you guys see this one, whatever you guys see, whatever you guys visualize, this one is P is read as not P and called negation. The truth condition for connectives. P and Q is true when both P and Q are true, as we said previously. So there has to be, either side has to be, P side and Q side has to be true, otherwise if it's not true, if 80% is true and 1% is false, it makes it false. So each side, both side has to be equal. If one side is false, then the other side is false too. That both side has to be true in order for this one to be true. P or Q is true when P or Q or both are true. So this side has to be, both side has to be true in order for this one true is. So if doesn't matter if one side is true and the next side is the other side is false, then it still is true. It is false when P or Q are both false. So this one is totally different, opposite to the AND. The OR works different, even in computer science it works different. So this has to be true, it makes it true, false to make it false. But if it's true, false, it makes it true. If it's true or false, true, it makes it true. So this one, but this guy is different. If this guy is say 99% is false and 1% is true, then this makes it true. That's how the OR behaves in mathematics and computer science. If P then Q, or P implies Q is true when P is false or Q is true, or both. So it's true if P is false, the first bit, and we're going to see in the next slide what we mean by the first bit. The first bit, and there is a two bits here. There is first bit, and you guys in here it says or if P then Q, and Q is true or both. So if the first bit is false and the second bit is true, then it's true. So if the first bit is true, the second bit is false, then it makes false, and it's false when P is true and Q is false. So we're looking at the Q because that's a consequent, that's a conclusion, that's this bit is conclusion. So there is two bits here, and I'm going to show you guys in the next slide what I mean. P double-headed arrow Q, P if and only if Q is true when P and Q are both true or both false, and it is false when P and Q have opposite truth values. Not P, our negation, not P is true when P is false, and is false when P is true. Implication, as we said in previous slide, implies. An implication, our conditional, is a molecular statement of the form P implies Q, where P and Q are statements. We say that P is the hypothesis or antecedent, Q is the conclusion or consequent. As we said in the previous slide, we look at the P. If P is this bit is it doesn't matter if this bit is true or false, but we look at the Q. If the Q bit is false, then the whole thing becomes false because the consequent is false. An implication is true provided P is false. We look at this guy, hypothesis is false, and Q, which is conclusion, is true or both. So this guy here, the P, even if it's false, and this guy here, Q, if it's true, then it's true or both. If it's both true, then it becomes a true, and false otherwise. So the false, if this guy is true, this guy is false, then it's false. In particular, the only way for P implies Q to be false is for P to be true. This here, hypothesis or antecedent, is to be true and Q to be false. So this guy here, we look at this guy. If this guy here, Q, our conclusion or consequent, is false, then it's false. It makes it false. In mathematics, the most common type of statement is the implication. This guy is here, implication. It is important to remember that an implication is a statement and therefore is either true or false. The truth value for the implication is determined by the truth values of its own two parts. To agree with the usage above, we say that an implication is true either when the hypothesis is false or when the conclusion is true. This leaves only one way for implication to be false: when the hypothesis is true and conclusion is false. So we come here and we see that true value of the implication is determined by the truth values of in two parts. There is a two parts, as I said to this one. We say that the implication is true either when the hypothesis is false or when the conclusion is true. Even if this one is false, this one is true, then it's true. And if this one is true, this one is false, it makes it false. Logic, statements, and truth. So we say let P represent statement birds can fly. P has the truth value of T because this is a true statement because birds can fly. And we say let Q represent the statement 20 is less than 10. Q has truth values of false because 20 is not less than 10. 20 is greater than 10. So we have a P represent which is true, and we have a Q which represents false. And we say against this wedge shaped P and Q, we say bird can fly. So the P1 represents true, which we're going to bring this one down. We say birds can fly, which is true, and 20 is less than 10. So T and F, true and false, becomes false. As we said in the first video, that even if 99% is true and 1% is false, then it becomes false. So here we have a bird can fly, which is true, and on top is true, and 20 is less than 10, which is false, and true and false, it makes it false. P or Q, birds can fly, or 20 is less than 10. So this behaves quite opposite to the end, and we say true or false makes it true. So even if 99% is say false, 1% is true, then it makes it true. So P implies Q. As we said in a previous video, there is a 2 bits in this one. So if there's the first bit, and that's the second bit, which we call the consequent, and if the birds can fly, then 20 is less than 10. True implies false, makes it false. So if this bit is false, then it's false. Even if it doesn't matter if this bit is true or false. So if this bit is false and this bit is true, it makes it true. So if, because the conclusion is false, then it's a false. So that's how the P implies Q behaves. The only way for implication to be false is for the if part to be true, and which is this part, and then the part to be false, and then the part to be false, which is this part. So we have a 2 parts. So if we say, example, if 10 equal to 10, then birds have 2 wings. So 10 equal to 10 is true, then birds have 2 wings, which is true. Hypothesis and conclusion is true, so the statement is true. If 0 is equal to 10, then 20 is equal to 20. Here the hypothesis is false and the conclusion is true, so the implication is true. So if you guys pay attention here, the hypothesis and conclusion is true, it makes it true. The hypothesis, which is 0 is equal to 10, which is false, then 20 equal to 20, which is true, and the implication is true. If 10 is prime number, then moon is round. Hypothesis is false because 10 is not prime number, then moon is round, and the conclusion is true. The second one, the second bit is the then bit is true and is true, then implication is true. So P, double-headed arrow, birds can fly if and only if 20 is less than 10. True if and only if false makes it false. P, if and only if Q is logically equivalent to P implies Q, and Q implies P. So here you guys pay attention that P, which is the birds can fly, if and only if 20, which is this bit, the second part, is 20 is less than 10. P is logically equivalent to true if and only if false makes it false. So P, if and only if Q is logically equivalent to P implies Q, and we look at here, we have and, Q implies P. So we have an example. Given an integer n, it is true that n is even if and only if n square is even. That is, if n is even, then n square is even, as well as the converse if. So we have example here. I'll give you the small example. Given an integer n, that's we represent this integer as n, it is true that n is even. So when we have a number which represent n is even, if and only if n square is even. That is, if n is even, then square is even, as well as the converse. If n square is even, then n is even. So we have both ways. If you guys look in here, we have n, if and only if and only if n square, we have n square, it goes there, e implies n implies n square, so we have and, then we have the other way around, which is converse, n square implies n. So that's what is here. So if you look in here, n implies n square, and we have an and here, and here this is a wedge shape, then we have an n square implies n, which is a number. So it goes both ways. So the first bit is a P implies Q and Q implies P, so it goes the other way, this converse. So that's what we mean. Logic, statements, and truth continue. So we're still in statements and truth, and we'll continue our conversation. 20 is greater than or equal to 10, and not false makes it true. So we go for the second one. which is the Q part. 20 is we go the other way around. Instead of 20 is less than 10, we say 20 is greater than and equal to 10, which we say not false, makes it true. So the second part here, not P or Q, which birds cannot fly. So we have a P, not P, birds cannot fly. Our 20 is less than 10. So not true or F, false, makes it false. Here we have another condition here, not P or Q. So neither birds can fly nor 20 is less than 10. So not true or false then is equivalent to not true, makes it false. So this guy here, we say is logically equivalent. So we say this, the three here, you guys see here, the three bars here, we say this one is logically, and we say it's equivalent. So this guy here, we say that neither bird can fly nor 20 is less than 10, not true or false, which is equal to, equivalent. This is logically equivalent. Not true is false. So here we have not P or not Q, birds cannot fly, and 20 is less and birds cannot fly, and 20 is not less than 10, which is not true or not false, is logically equivalent to false and true, which makes it false. So the last bit, you guys pay attention, not P or Q, birds cannot fly, which makes it not P, and 20 is not less than 10, which makes it not Q. So not true or not false is logically equivalent to false or and to false and true, which makes it false. So the last bit is a little bit confusing, and the three bars here is called logically equivalent. Alright guys, that's it for this video. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.